Hello everyone, so today's Geeks for Geeks daily problem is string permutations. We have been given a string as an input and we need to return all the possible permutations of the string. The constraint of the string is that the size of the string will be up till 5 only, and expected time complexity is n into n factorial. So it is very clear that we can use a recursion here because the limit is very less. I mean, the size of a string is up to 5 only, and at max the space time complexity will be n factorial into n. So 5 factorial is 120 and into 5, that is 600. So that is around 10 key power 3. So yes, we can perform recursion. Now let's see what will be the approach for solving this problem. If the string given is absg, we need to return all the possible permutations. So if there are four possible if there are four characters in a string, how many possible how many strings are possible from that given string for all the permutations? It will be 4 factorial, right? Why 4 factorial? Let's see. absg, we will see a B, S and G. So this is the string that has been given to us, and its size is equals to 4. We need to find out how many permutations are possible from this given string. It will be 4 factorial. How 4 factorial? Let's see. Suppose these are the 4 locations that need to be filled, and if and these are the 4 letters and these are the 4 letters. In how many ways can you fill the first place? That is 4. In how many ways can you fill the second place? That is 3, because I had already filled one character here. And how many ways? Similarly 2 ways, and here 1 ways. So the total number of ways will be 4 into 3 into 2 into 1, that is equals to 4 factorial. So the number of possible strings is 4 factorial. I hope this was clear to you. Now let's move on to the further recursion part. We will be using a final answer vector that will be storing the answer. So in the starting, I will be starting from this index. Now at starting from this index, what I will do is I will be swapping this index with this index itself. So it will give a, b, s and g. It will give a, b, s and g. And in the second, I will be swapping, and in the second recursion call, I will be swapping this with this. So it will be b, a, s and g. And then I will be swapping a with s. So it will be S, B, A, G. And then now I will be swapping A with G. So it will be G, B, C, A. Now what? Now my index will move on to this location. Now my index will move on to B. And at B, I will be swapping B with B. I will start my for loop from this index to this index. So I will be swapping B with B. So it will be again A, B, S and G. A, B, S and G. Now what? I will be swapping B with S. So it will be A, S, B, G. Now I will be swapping B with G. It will be A, G, S, B. Similarly, we will get many possible recursion calls, and my base case will be when my index hits s dot size. In that case, what will be the situation? The situation will be that my index will be pointing to an absurd location out of the string. What does this mean? This means that we have traversed the whole of the string, and we need to push the answer into the and we need to push the string into the answer, and we finally return this answer vector. I hope this was clear to you. Now let's move on to the coding section. Actually, I had made a wrong recursion call over here. These recursion calls will not be made simultaneously. Sorry for that. Yeah, so what I did, I just made the recursion call from B from the 0th level itself. The recursion call from B will not be made from here. Instead, it will be made from here. Instead, it will be made from these strings. So I hope I had rectified my mistake, and now let's move on to the coding section. So I had made a final string vector, uh, and I had called the recursion call from the string s and index 0 with an answer has been passed to store the final string, and I had sorted the string answer because they are asking for permutations in lexicographically increasing order. and finally I am returning s. Acha, now this is a recursion function. So in case my index is greater than equals to s dot size, what does this mean? This means that my index is completely over and I had traversed over the whole of the string. Now I simply need to push back the answer. Now I simply need to push back the string s into my answer, and I finally return from here. Now what, the same thing that I told you, that we will be starting from the current index and going to the last index and swapping each and every possible indexes. So this is, we are swapping the indexes s of I and s of index, and calling the further recursion calls for index plus 1. Also note that since we are passing s by reference, we need to backtrack. I mean, at each recursion call the changes will be permanent, and while backtracking we need to revert those changes, and in the end we will simply return. I hope this problem was very clear to you. If you found the problem as helpful, solution as helpful, please do subscribe and hit the like button. Also press the bell icon so that you may get any further future notifications in case I upload any future video. Thank you.